type of problem that we have are elevator problems. So let's talk about that. So now we're going to imagine that we have a ceiling and there's some kind of winch system here, and we have an elevator that's hanging from a rope. So the only forces that are acting on it will be the weight pulling down on it and the tension in the rope pulling up on it. So if it's at constant speed, right, the acceleration is 0, and the sum of all forces has to add up to 0. So that means that the tension has to be equal to the weight. Well, let's talk about that. The mass is 2,000 kilograms. So the weight is 2,000 kilograms times 9.8 meters per second squared, which is going to be 196,000. Yes, newtons. .0 newtons. 19600 with 2 O's. So the tension would just be 19600 newtons. So the next question is, what is the tension in the rope if it accelerates upward at 2 meters per second squared? Okay, so now the sum of the forces are not equaling 0, right? The sum of the forces are going to cause it to accelerate. So T plus Fg is going to be equal to ma. Now, when we have this, and we're going to add vectors, we have to assign a positive and negative direction. This will be a positive number and this will be a negative number when we plug it into our equations. So really, it's going to be T plus negative 19,600 newtons equals the mass, 200,000 kilograms, times A equals positive 2 meters per second squared, because it's going upwards. So T is going to be equal to 4,000 newtons plus 19,600 newtons, and T will be equal to 23600 newtons. Now, does that make sense? If you're accelerating upward, this tension vector should be bigger than the weight, right? And it is. It is much bigger. But what if it was moving downward, right? What if it was moving downward? Well, if it was moving downward, then A is going to be negative 2 meters per second squared. Our net force is still going to make it accelerate. It's still going to be tension plus weight equals ma, and it's still going to be tension plus negative 19,600 newtons equals 2,000 times negative 2 meters per second squared. I'll put that over here. So when we do this, we're actually going to end up with tension equals, we're going to have to add 19,600 to both sides, negative 4,000 newtons, because negative 2 times 2,000 is negative 4,000, plus 19,600 newtons. So the tension would be 15,600 newtons. Does that make sense? Well, if we have an elevator and we're accelerating downward, so this is the direction of our motion, right? Then the weight has to be bigger than the tension, right? It's unbalanced in that downward direction. Has to accelerate downward. So we're going to draw our generic equation and get our generic equation using just this basic diagram with tension up and weight down. Our generic formula is going to be T plus weight equals ma. But when we start plugging numbers in, we have to remember that these are vectors. So if we're going to plug in a weight value, we're going to have to plug in a negative number because it's negative. And if we're moving upward, we're going to have a positive acceleration. If we're moving downward, we're going to have negative acceleration. If we're not accelerating, acceleration is 0. So that makes this whole thing 0. And so we just know they're equal to each other. All right. And our last problem with tension is a mass hanging. So let's imagine that we have a stoplight. Okay, we have a stoplight that's hanging by 2 ropes. Okay, this will be rope A and this will be rope B. I'm going to give you, this is 30 degrees and this is a 60 degree angle. 30 and 60. Let me write that more clearly. 30 degrees. All right. So let's talk about what's going on. We have a weight, and we have tension B and tension A. So A is pulling to the west, and B is pulling to the east. B is pulling up, and A is pulling up. Notice I drew in these vectors. So really my diagram looks like this. Weight, BY, AY, BX, AX. These are really the vectors that we're dealing with. So what's going on in the Y direction? Well, all of them add up to 0, right? It's hanging there, we hope. So that means that AY plus BY has to be equal to FG. So let's write some information down over here. So FG, this is 100 kilograms. So the mass is 100 kilograms because that's the units that we're given. FG is going to be 100 times 9.8, which is going to be 980 newtons. The formula for AX is going to be A cosine of 30, and AY is going to be A sine of 30. BX is going to be B cosine of 60, and BY is going to be B sine of 60. So what I know so far is that AY, which is A sine of 30, plus BY, B sine of 60, has to be equal to 980 newtons, and that's all I know. What about in the X direction? Well, all of those add up to 0. And the only 2 forces in the X direction are AX and BX, and they have to be balancing each other out. So A cosine of 30 equals B cosine of 60. So let me just solve for one of those. A equals B cosine of 60 all over cosine of 30. So what I'm going to do is on the next page, I'm going to rewrite this statement, and then I'm going to substitute in this value. So we had A sine of 30 plus B sine of 30 equals 980 newtons. We knew that A was equal to B cosine of 60 all over cosine of 30. I'm going to substitute that in here for A. So if I do that, I get B cosine of 60 times sine of 30 all over cosine of 30 plus B sine of 30 equals 980 newtons. All right, so this is kind of a mess here. But I know that sine divided by cosine is tan, so I'm going to make it look a little prettier. Cosine of 60, since sine and cosine are both of 30 degrees, I can say that is tan of 30 plus B sine of 30 equals 980 newtons. The reason why I substituted in was because I had two unknowns here, and so I had to use the other equation to get an expression to get rid of one of those so that I could have only one unknown. Well, cosine of 60 is 0.5 and tan of 30. So I'm just going to take cosine of 60 times tan of 30. And that decimal is 0.823. So this is 0.823b plus sine of 30, which is 0.5b equals 980 newtons. So 0.5 plus 0.8 would be 1.323b equals 980 newtons. So B is equal to 980 divided by 1.323. So B is going to be 741 newtons. And if I put it in here, so 741 times the cosine of 60 divided by the cosine of 30. So 741 times cosine of 60 is 370.5 divided by cosine of 30. And that should give me, tension A is 428 newtons. That was a lot.